All right, dude, we are live. What's up, guys? This is Dem Keys, and today we are going to continue learning about PWM stuff in the ESP32. More specifically, we're going to be exploring a bunch of the APIs surrounding very simple PWM stuff, specifically LEDC, the LED controller PWM, and not the motor control PWM. Sorry. Um, That being said, hold on. I do have a question that I need to ask Gemini. I'm gonna type out the question before I forget it. Okay, hold on. Okay, hey, I'm learning about ESP32 PWM stuff. Um, I'm wondering, other than, no. So I've learned that we have specialized LEDC and MC PWM. So LEDC PWM and MC PWM hardware. What I'm wondering is, in terms of general purpose PWM, is there something even more generic than this? Like just bare bones PWM, if that's even a thing, um, or is LEDC as simple as it gets? Right now, while that answer comes in, holy shit, dude, I've been busy. I've been busy since yesterday's stream. I have been doing a bunch of research on Term. I've been having a pretty detailed, very educational, very informative conversation with not Gemini, but GitHub Copilot. And Copilot has been incredibly helpful in helping me understand. Give me a second. I need to, I'm going to show you guys a diagram that Copilot, how many do we have? Well, okay, this one might say sat, not fry. I think so. Yeah, this one will say sat. I'm just going to copy that entire diagram and then I can post it or paste it. Then I can paste it in Tmux so it can be um, shown on stream. Let me also open up our project. Oh, give me a second. Yeah, this is the one. Okay. All right. Awesome. Man, I'm so glad that I discovered this shortcut of space Q and then lowercase s. Usually I would either do L to restore the last session if it was literally the very last project that I had opened up, or I would do uppercase S, which would bring me into this menu, which is also very convenient, by the way. This makes it so I can open up NeoVim from literally any directory, and I can still have access to one of these sessions and um, you know, open up that specific session. However, it's pretty common for me to CD into the directory, um, like for example, this ESP proj 05, and then open up NeoVim in there. That's why I usually open up NeoVim using a dot to denote, open it within this directory. So for me, the space q and lowercase s is really useful because it directly like restores the session. Okay, now that being said, I'm gonna paste this thing. Holy shit, it has been so informative. I've been having a pretty long conversation with Gemini, not Gemini, GitHub Copilot, more specifically Claude um, Haiku. That's the model that I've been having a conversation with. Also, dude, I need to get back on like the LLM thing. LLMs, agents, and possibly Le Robot as well, because they've been making a bunch of new developments, a bunch of new advancements in it. They are actively developing that library, and since I do plan on getting into robotics, once I've got the digital electronics basics down, since I do plan on getting into robotics, I kind of want to familiarize myself with the robot. We have actually done a bit of the robot stuff on stream. Give me a second here. I just realized something. We might be on a tiny bit of a delay. I didn't take that into account when I was doing all of this stuff and like demonstrating things. Give me a second. I want to see how long that delay is. Oh, holy shit, that's a long delay. That is like a good 5 seconds. That's crazy. Well, anyways, so yeah, I need to get back on track with that. Actually, yeah, now that I remember, let's go back up here and real quick just add things to this. Well, now I'm already this is what I've been up to. This, I actually followed through with it. This is a task I created. I was like, okay, I need to use GitHub Copilot to understand WesTerm. WesTerm is an open source terminal, and so the code for it is up on GitHub. So I decided to use GitHub Copilot to analyze the entire WesTerm repo and analyze the entire source code of WesTerm. I don't know if it does the entire thing at once, though. I tell it to, but I don't know if it does actually analyze like literally the entire thing, or is it mainly when I ask it a very specific question, and then it determines that, hey, okay, this might be in so and so location, so let me go and analyze all of that code. I don't know what its analysis workflow is like. But yeah, that being said, I did ask it to analyze the entire repo, and then based on that I have certain questions, so explain so and so concepts to me. I started with workspaces and sessions. I didn't plan on getting into domains just yet. I didn't even plan on getting into GUI instances. It just so happened that in explaining workspaces and sessions to me, which I found out sessions are the concept of sessions is it kind of relates to multiplexing in WesTerm, and so we kind of ended up going into the multiplexing path. Anyways, I was planning on first understanding workspaces, and then going into the multiplexing side, but I kind of got the answer to both of them, and from there I branched out and I got a much deeper understanding. So much so, I mean, I don't want to post the entire conversation just yet because there's some information in there that I would like to keep private. Um, However, I do have a diagram that I want to show you guys that GitHub Copilot generated to help me understand the hierarchy, because we were having like a very detailed conversation. Gemini would not Gemini. Claude would give me an explanation about the stuff I was asking an explanation for. Then I would ask certain doubts based on that, and and then in responding to those doubts, Claude would give me even more information, and we just kept on continuing from there. This is why I love LLMs so much. Um, you can have a you can literally have a conversation. I wouldn't be able to do any of this if I was just sticking to googling things. But having Claude, having GitHub Copilot analyze the entire repo and then answer my questions, because now the LLM understands what this project is about, and the LLM actually has access, or let's say the model, it actually has access to the source code. So it can read the source code, and based on that, it can give me factual answers that it knows are true. That is something incredibly powerful for me. The fact that I'm able to do this, it saves me so much headache of having to Google things. And in this case, I actually did try to Google things. I even tried asking Gemini, But Gemini's information was in some cases it would be right. In some cases it wouldn't be fully accurate. There would be some minor differences here and there. And I figured the absolute best way to get answers on this is to ask an LLM that has actively studied this entire source code, and an LLM that can go and analyze different parts of it to then determine that, oh yeah, this is how things are done. Okay, so I need to. So this is VTuber app. This is new focus list. Um, Polars. Let's add that in. We So far I've been doing okay. Get back to learning Rust basics through Gemini. Then we have our um, what do we have? We have deep learning. We need to get back to deep learning. Deep learning fundamentals. Let's say FCNN, CNN, RNN, and transformers. Speaking of transformers, um, LLM course, agents course, Le Robot course. So I also want to, get more familiarized with the Transformers library, but that's going to happen as I'm learning, as I'm going through the LLM course, because that's kind of how they introduce you to not just Transformers, but their various other libraries as well, like tokenizers and diffusers, and I think datasets also gets introduced there. And there's a couple of other things. Maybe there's something audio related. I don't remember. But yeah. So I don't need to explicitly mention transformers, even though transformers is like very heavily being used, and it is uh, what I'm heavily focusing on as well. Fucking content pipeline, dude. I need to continue working on the content pipeline. Content pipeline. V2 now, I guess. I don't know. What am I calling the content pipeline now? Actually, it's not V2. V2 was for the VTuber app. So we're just going to say content pipeline. Um, check node, because I did create a separate node for this. Content pipeline V1 is what I call it. So there was a polar sliding 60-second window. I completely forgot about this. Learn how to use the outlines library, then learn how to remove silent segments. That's more of an FFmpeg kind of thing. Then generate video metadata using NLP and LLMs. I think I'm just gonna focus on LLMs. Though, okay, no, I'm I can't say that for sure because it's kind of interesting. I at this point, it does seem like I would be better off just crafting prompts properly and using the outlines library to get an LLM to give me all of the answers for the specific questions that I'm asking, because the LLM will be able to do the majority of the things, at least from what I've understood, an LLM would be able to do the majority of the things that specialized NLP models would be doing. In fact, the LLM might even perform better, depending on. Give me a second. In fact, the LLM might even perform better, not in terms of performance, but in terms of quality of the output, because the LLM has a much better it has the ability to understand context much better than specialized NLP models. That being said, I have to find like the right balance, because there are specialized models out there as well. A lot of them are transformer based. So like maybe I could try to not get sucked too deep into the NLP thing, because I in the past I had this thing where I was like, okay, maybe I should try and learn NLP related stuff. Um, But there's just so much that I have to do that I don't know if I'll be able to give time to it, which is unfortunate, but it is what it is. I'm busy. I've got so many different things that I need to be doing. I need to prioritize them, and learning NLP just isn't at the top of my list. Learning about LLMs and building LLMs and how LLMs work, that is definitely at the top of my list. And it just so happens that a lot of things that specialized NLP models can do, LLMs can also do them, given that you give it accurate instructions and outlines is what's going to help me get the output in the exact way that I want it. That being said, there are also, the specialized models that are transformer based, and them being transformer based helps with that context thing that I was talking about, because that apparently helps them understand nuances a lot better um, than let's say non-transformer based NLP models, the legacy NLP models, let's say. The legacy NLP models do have one massive advantage over transformer based models, and that is that they will be much faster than transformer models. So if you are doing, let's say, a real time kind of thing, or if you are working with embedded hardware or very, let's say, low end hardware, then you're better off sticking with the legacy methods. But if you're doing one-off things, kind of like what I'm doing with the content pipeline, it's not it's not like it has to be real time. It has to, for lack of a better term, crunch the numbers once, and that's it. It crunches the numbers for any given video. It crunches the numbers, produces the output, and then that's that. Okay, so right. What did I put in here? This is from like last year. Continue working on the content pipeline, both on and off stream. Holy shit, this has been 1 month, 1 month and 10 days. That's crazy, dude. Okay, what was this? Content pipeline, Godot with Rust. That just got pushed to the side. Holy shit. Legacy NLP, probably not going to be happening at this point. So let's get rid of that. Gemini teaches analog electronics is not happening because I'm reading the Forrest Mims book. Um, I need to make more progress with that, by the way. But before that, I need to finish my conversation with, not finish, but like continue that conversation with Gemini, where Gemini is explaining to me how atoms, electrons, protons, neutrons, charges, and all of these things, how they work together, how they're connected to each other, how they behave, how they change behavior of other things, how they influence things, all of that stuff. I want to understand that, because that is the foundation on which I'm going to build. Uh, what am I trying to say? I'm going to build up on that foundation. That's the foundation that I'm going to build on. That's the foundation on top of which I'm going to be learning about semiconductors, in this case, more specifically silicone, and also that whole thing about p-type and n-type and stuff like that. All of that, it builds on top of the foundation of how atoms and electrons and protons and stuff work. So I would like to get a proper understanding of how these things work. Various details like, okay, let's say, okay, what is an atom? In an atom, you have protons, neutrons, and electrons. What do the protons and neutrons do? Because they don't really move. It's the electrons that are moving. The protons and neutrons, they're like, apparently they're tightly packed, and they're like stationary in the nucleus, or they make up the nucleus. And then you have electrons that are sort of orbiting the nucleus. I don't even know if it's orbit or if it's like some other kind of movement. So all of this stuff I need to understand. um, also how these atoms apparently make up our solid objects. I need to look into that as well. I don't remember if I mentioned that in the prompt, but I definitely need to look into that as well. And this is great because holy shit, dude, I'm learning and understanding analog electronics on a level that I didn't understand before. Um, and I'm pretty happy about that. I'm pretty excited about that. Right. So, um, I was gonna show you guys the diagram that Gemini drew to help me understand this. I'm going to paste the diagram. There's a bunch of stuff that we spoke about in this conversation, and not Gemini. I keep saying Gemini. I'm so used to saying Gemini. Um, Claude, GitHub Copilot, help me understand. I'm going to show you that. So, I guess let's yank this entire thing. Yeah, let's yank that. I do not remember. Okay. All right. So we're going to copy this and real quick, I'm just going to test it out here. Okay. This, yeah, we should just be able to paste this. So I'm going to come here in Scratch and we've saved this. We're going to go back here. Let's create a new Scratch file. Save this, paste. This is the diagram that Gemini generated. And this is an excellent, actually, hold on. This is not, no, wait, sorry. Uh, this is one of the prior diagrams. The one I was planning on showing you guys, the one I was trying to show you guys, which gave me like an incredible understanding of how these things are working. That is this one. Hold on. I'm gonna copy this. We're gonna yank it. And we need to select this entire thing and paste. This is the diagram. This is crazy. So Gemini explained that, okay, you have one process called WesTerm GUI. Usually when you start up WesTerm for the first time, actually, give me a second. I just realized that I forgot to open up my, oh, yeah. Sorry, I had TikTok open and another VTuber's. I don't even know if that came through uh on stream, but I had TikTok open and another VTuber's clip was playing. Dude, I need to hurry up with there's so much interesting stuff happening on stream and I don't have the content pipeline set up to be able to create these clips. That's crazy, dude. That's insane. Give me a second here. Just opening this up. Though, okay, if I wanted to get started like right now, I kind of already have the tools to do that. Because, for example, I have an entire massive. Oh, that's not gonna work. Yeah, that's not gonna work. I was about to say that I have the ability to generate a massive transcript, right? I have that part of the pipeline already set up, but then what I don't have set up is the ability to analyze that entire transcript. And I just remembered that the reason that we are not just dumping the entire transcript into the LLM is because of the way that LLMs work. They're not that great with massive text. Um, what they end up doing is they pay attention to, and this would be something interesting to explore in LLMs. I have no idea if we're going to learn about this when we are going through the LLM course, or if I'm going to have to uh, if I'm going to have to learn this in some other way, like because I want to also look into the tech for developing LLMs, not just large language models, but like um, other types of language models as well. You have like, I think you have vision language models, which can, based on images, they can give you answers. Uh, I don't have other examples to give, but like there are different types of language models. So basically, they don't just take text as input; they take other stuff as input as well. So like in general, I want to learn about language models and how that tech works. And I think the best way to do that is to sort of build my own language model. Obviously, it's not going to be nearly as good as an LLM from one of the bigger competitors, but just just building my own and um, getting the thing to work, I feel like that would be an accomplishment for me. And also, it would be a great learning experience for me. Keeping accomplishments aside, it would just be a great learning experience for me because it's going to teach me how these things work. And then I can apply that knowledge when I'm using other bigger language models. I can also use that knowledge to then fine tune. That's what I was trying to say. I can use that knowledge to then also fine tune, other language models to perform in different ways. Though I believe the fine tuning part does get covered in what do you call it, in the LLM course. But yeah, anyways, I noticed that when you start up Westterm, the first thing that, or I'm not going to say the first thing, but like when you do start up Westterm, a Westterm GUI process starts up in your BTOP. So you can see it in BTOP. It doesn't start, I keep saying it starts up in BTOP, but what I mean is that uh, this process starts up and you'll then be able to see it in BTOP if you use BTOP as your task manager. I use BTOP. So you can see Westterm GUI, the Westterm GUI process in BTOP. um, and I was curious about like how how the Western GUI process is connected to the windows, the GUI windows that we see. Is there like a different concept of, back end windows versus front end windows, and how are windows connected to domains and workspaces and stuff? There's a lot of like moving parts involved here, and I was very confused about how things are connected with each other. That's okay. Are we live again? I think so. Hopefully. Just a second. Okay. All right. I think we are live now. Um yeah. Fortunately, the stream did not crash. So that's good news. Uh yeah, yeah. We were saved. Awesome. Great. Sorry, zoned out. Okay, so Gemini was explaining to me that, no, not Gemini, Claude was explaining to me that you have actually, okay, I was talking about like there's various moving parts involved. So I was curious about how these various moving parts work together, because something that I noticed, just as an example of like, multiple different moving parts, um, something that I noticed was, let's say the concept of workspaces. Okay, you can create by by default, every window that you create, it's going to be part of the default workspace. Generally, it's Windows that gets set up as, or GUI windows rather, that gets set up, well, Mux windows, I guess you can say. That's also another interesting thing. The concept of Mux windows. We also explored that concept. That's apparently the back-end representation of these windows, and the front-end representation is basically the GUI window. So the Mux window is essentially the data and or the data layer of that window, and GUI window is the rendering layer for that Mux window. That's one way to look at it. But what I noticed was that you can have, okay, so let's say you created a new workspace, and you have three different windows that are part of that workspace. Okay, and let's say you have another workspace. So the first workspace, let's call it workspace A, and then another workspace, that's workspace B. And let's say you only have one window in that workspace, not tabs. I'm talking about like full GUI window. Let's say you have only one window. When you are in workspace one, when you have workspace one active, you will be able to see, and I think at any given time, you can only have one workspace active, and that is, I believe, per process. Um, so you can have one workspace active, and whichever workspace is active, whenever it's activated, all of the Mux windows that are part of that workspace, there will be GUI windows created for it. And if there are already some GUI windows active in your scene, like within your setup, if there are already a couple of GUI windows active, new ones don't need to be created. The other ones can just be reused. They'll just display something from the workspace that you have just activated. And this concept was interesting to me because it was essentially like changing layouts. You have these different Mux windows, and so GUI windows, and different windows can be part of different workspaces. And depending on which workspace you currently have active, the respective windows will be shown. It's the reason why it was kind of like interesting for me, and I had like a hard time wrapping my head around it initially, was the fact that when you switch workspaces, it will actually create new GUI windows if it needs to. So if you are in a workspace that currently only has one window, and then you switch to a workspace that has three windows, so let's say, given our ongoing example, we have workspace A that had three windows, we have workspace B that has one window, and we are currently in workspace B, and then we switch to workspace A, it's going to create two extra windows. So it can then show all three of the GUI windows. So it's full on GUI windows that are constantly being like replaced or created and removed and so on. And that's super interesting to me, and they persist, they stay alive until you manually close them. It's kind of an interesting, like, making them in like a detached state. It's not even detached, it's more like inactive state. They're not, that workspace is not currently active. However, if you close the workspace that you're currently in, you close the window for that, there is no GUI window, right? But the other workspace is still alive. So the Western GUI process is going to still remain alive because you haven't closed that workspace yet. You haven't closed those windows yet. So it's kind of interesting. There's like a lot of very interesting functionality within WesTerm. And dude, I'm loving whatever I'm seeing in WesTerm so far. And this is going to be the terminal that I stick to for like a very long time. I've found the terminal that I'm super interested in because of the customization, the customizability of it, and the ability to write plugins for it, and also just all of this extra stuff that I'm seeing, all of this new stuff. I shouldn't even call it extra. This is like amazing functionality that is just available within this terminal. Multiplexing, for example, this functionality is just available out of the box. There's a tiny bit of configuration that you have to do, but it's available out of the box. So apparently you can fully replace your TMUX workflow with Westterm's multiplexing workflow. Okay, so Claude explained. I just remembered that we are supposed to be doing a stream about PWM, and I'm here talking about this. But like, this is what I've been busy with, like all of yesterday and most of today. It's been, dude, holy shit, it's been so informative. So okay, you have this process. This is a single OS process. This is what you're going to see in your BTOP, named Westterm GUI. Within this, you have something called a MUX. The MUX is what's responsible for um, storing and managing windows and tabs and panes, domains, clients, etc. Okay, client. Apparently, the client is just like, it's one thing. It says it's one per mux, and it identifies the current client. I think the client also has to do with the terminal itself. I need to look into that. I don't want to accidentally give the wrong information there, but you have one client per or one client info. Oh, it says this is a GUI's identity. So this is a GUI client. Okay, right. So then you have domains. This is the part that I'm currently exploring because I've been asking Gemini because each I initially thought that each window is part of a certain pane. It's not just each window, it's each sorry, did I say part of a certain pane? No, I meant I initially thought that each window is part of a certain domain. It's not each window. Apparently, it's each pane, not even each tab, because within a tab you have a pane, and the pane is where your actual execution happens. That's why within one tab you can have multiple panes, and each of those panes will be a separate shell. It's a separate like execution environment. Okay, so you have the concept of domains. By default, like if you haven't set up like a if you haven't set up an SSH domain, a remote domain of some sort, by default, you're just going to be running the local domain. That's your default thing. Um, I also learned this. You can set up, I haven't set this up yet. You can set up local multiplexing. I have to explore that. I want to explore local multiplexing before I move on to um, SSH domains, which basically give us the ability to do remote multiplexing. So the idea is the back end of those windows and their tabs and panes and so on, all of that will be stored and managed on the multiplexing server, the MUX server, on your remote machine, or let's say on one machine. Let's call it machine A. All of that is going to be stored on machine A, but then you can SSH or you can attach to those windows and have the GUI representation be rendered on machine B, C, D, E, whatever. That's basically how this is meant to work. It's slightly different um, in terms of workflow. It's slightly different from how you go about doing things in TMUX, because in TMUX, what I do is um, I attach to it. I basically open up a terminal, and then if I'm on a machine across the network, I have to first SSH into the machine that actually hosts all of the TMUX sessions, and then that gives me a shell, and from that I attach to one of the TMUX sessions. Apparently, it works slightly different in Westterm. Um, I don't know how the attaching and detaching works. What I do know is the way that it's been implemented, those those windows are going to show up as native windows for you. So they'll show up as native GUI windows. And instead of I don't know if you guys are able to see it in the bottom right of the screen right now. Yeah, in the bottom right, you can see it says local. That means local domain. I'm guessing when it's a remote thing, then it's going to say remote domain or SSH domain or whatever that kind of domain is called. So anyways, I'm exploring the concept of domains as well. Apparently, this is where things execute. I'm still, like I said, I'm still exploring the entire concept of domains, like because I haven't fully understood that thing about where things are executing. Um, all I understand, like my way of looking at it is, you have a parent process that's spawning these child processes, which might be shells, and then within those shells you have the execution happening. I'm I'm not too I'm not too knowledgeable on that front, so I have to do a lot more research to understand what's going on there. Now, keep in mind we are within one mux. This also took me some time to understand. It's this concept of a mux. Let me read the conversation so I can tell you exactly what a mux is in Claude's own words. Give me a second here. Oh shit. Okay, this is interesting. So sorry, I was going through this conversation, and I'd asked GitHub Copilot, how many domains can a mux have? And the answer is apparently as many as you configure. So there's no hard limit. You can have multiple. Um, there can be Unix domains, WSL domains, SSH domains. There's something called exec domains. I need to look into that. That's something to do with Docker. Apparently, I didn't know that's a thing. Um, but yeah. Hold on. Give me a second. I need to scroll back up to tell you exactly what a mux is. And I think today also I'm gonna spend the entire day after I'm done with the stream. I'm gonna spend the entire day just talking to Claude about this, just to be able to get more and more information on how things work, because I'm diving deep into this and I'm getting a pretty decent understanding of how things work. I haven't even gone into the multiplexing side of things. Apparently, even with the local domain, even without multiplexing set up, by default, you are using multiplexing to a certain extent. Because, I mean, okay, multiplexing isn't just about being able to attach and detach a terminal from, you know, from a session. Multiplexing is also what, holy shit. Multiplexing is also about being able to have multiple panes within one tab and have all of them have separate execution environments. Multiplexing is also about I believe multiplexing is also the reason why workspaces don't completely die when there's no active GUI windows. That's another interesting concept I need to look into. Not having any active GUI windows. Like let's say I started up WesTerm for the first time, and this is why I'm excited, dude. Like there's so much to explore with WesTerm, so many things to look into. And I have barely seen proper information on this. Like I kind of feel like I need to do a write up on this. I need to write the information to help other people out. Um I don't know. I don't know. Maybe I might need to. Hell, I might even, like, if I'm confident enough, I might even make a video on it. But I think the reading thing is going to be a lot more helpful. Oh, yeah. I was talking about Mux. Okay, quick thing here. Yeah, okay, okay. So, this is what Claude told me in terms of, like, what exactly is a MUX. So the MUX is the multiplexer core. The MUX is the central data structure that manages everything. It manages tabs, panes, windows, domains, clients, etc. And you can see that in this diagram that has been generated by Claude. You have a bunch of things coming within Mux, and it's only one Mux. This was a confusion that I had because I hadn't fully understood um, the concept of a mux. I wasn't sure exactly what a mux is, and I hadn't fully understood like what exactly it does and what it comprises of and all of that stuff. So as I was asking questions, Claude was replying accordingly. So um, it manages various types of info like the tabs, the panes, the windows, the domains. It's really interesting because you can I maybe I can show it somewhere here. How would I be able to show it to you guys? I'm within Tmux right now, but if I do it here, would that work or would that like I don't know. Let's try this. Westterm CLI um list. I need to be careful. Holy shit! I need to be careful doing this. Wait, what happens if I pipe this into bat? The wrapping thing is not any better. But yeah, this is the information that we get. This is what I was trying to show you. This is the information that we get. You can see a Win ID, a tab ID, and a pane ID as well. These are all independent from each other. That's what's crazy to me. Like these are all independent from each other. They have their own IDs. So you can do interesting things like um, I think it was based on the tab ID, you can activate a certain window using Westterm CLI. That's this tool. Oh, sorry. Oh yeah, okay. I was about to say sorry. It's not tab, it's pane. But no, you have activate pane. You also have activate tab. So yeah, okay, all right. Going back to this diagram, and also, well, yeah, going back to this diagram. So the Mux has client info. It has domains. And then it has the concept of Mux windows. These are your containers for your tabs, which contain panes. So within a Mux window, um, or well, Mux windows is the container containing the windows themselves. Each of those windows is a Mux window, or conceptually, I guess it's considered a Mux window. And this Mux windows thing itself is a list of Mux windows. And within each window, you have various information like the window ID, the workspace that it's currently a part of, the tabs that it contains, and that'll apparently be tab IDs. And then active, I believe it's to show which is the currently active tab. Uh, then within each tab, you have more information because tabs hold panes, and the panes have their own information. Panes, in fact, from what I learned, panes have their own separate section. I believe it's even outside of Mux Windows. So if we look here, yeah, you can see panes. Panes is like a separate concept outside of Mux Windows. Panes, it mentions here the actual terminals. This is where your actual shell is. It's not in the tab. The tab has at the very least one pane, and within that pane um, you have a shell. And so that's why one tab can be divided into multiple panes, and that way you can have multiple shells within one tab. Um, and yeah, this contains information about the panes. Then you have workspaces, and this is where it kind of the dots kind of connected. Like in the documentation, it mentions that workspaces are essentially just labels, but I didn't fully wrap my head around what exactly that meant. That workspaces are just labels. And then here, now it made sense that in workspace one, we can have multiple window IDs being mentioned. I wonder if one window can be a part of multiple workspaces. Yeah, that's something interesting to look into. Because I don't see why not, right? At any given time, you can only have one workspace active. If you can only have one workspace active, you don't need to worry about like duplicate windows. And so, um, if at any given time you can only have one workspace active, you could pass, duplicate IDs, as in, let's say window ID 1 could be a part of both workspace 1 and workspace 2. I should look into that. Yeah, I should look into that. Which windows I make a part of. Though, okay, um, they don't provide a way to select multiple workspaces, at least from what I've seen. They don't provide a way to select multiple workspaces. They give you the ability to make a window a part of one workspace, but they don't really give you the ability to like select multiple workspaces that the window will be a part of. If they do, then I haven't seen it. Holy shit, dude, I just noticed the time. Oh my God. We've been yapping for like 50 minutes, 51 minutes. I'm gonna stop the yap sesh here, and we're gonna, oh, sorry, wrong key. Okay, so we're gonna get back to this. We were looking into this yesterday. I did want to set up, because we're doing a separate timer, right? So I wanted to set up a different LED for the high-speed timer. So give me a second here. I'm just gonna grab this. Give me a second here. I'm just gonna grab this. Okay, we need orange, we need black. Then I need um here's some components ASMR for you guys. Okay, so um let's go for a green light, or we can do a red light. The red and blue combo would look nice. And then we need a resistor. Okay, brown, black. So that's 1, 0. And then orange is what, something in the thousands, I think. Is this a 1K ohm resistor? I'm not sure. I don't remember my resistor color codes. I remember that brown is 1 and 0 is black. So that helps with, oh, and I think red is the next one. So red is 2, because for 270 ohm resistors, you do usually see that color. Give me a second. I'm just going to Google this. Resistor color code. Okay, I think orange is the next one in line. I need to like print out I need to print out the color code chart or color code table and like have it plastered on my wall or something. Okay, orange is 3. So that would be a multiplier by 3. And so, well, multiplier by 3. So adding 3 did, oh, is this a 10K ohm? No, it's 1 and 0. Is orange 100 or 1000? Orange is 1K. Oh, red would be 100. So basically, the idea is that these colors, when you are looking at the third, if let's say we're talking about a 4-band resistor, let me show it on screen. Uh, I don't know how well you can see the colors, but yeah, let's say you have a 4-band resistor, and you have certain colors on it. The first and second band that you see, usually they would be for digits. So you just count the digit by looking at the resistor color code chart, and black corresponds to 0, brown corresponds to 1. So if you have brown, then black, that's 1 and 0. Your third band is meant to be a multiplier. So basically, um, you multiply the first two digits that you got, you multiply that by the multiplier, and that's how you get your resistance. The fourth band is supposed to be a tolerance sort of thing. So that tells you how accurate this resistor will be. The resistance could be a little bit below that, a little bit above that, and for the most part, you are okay in terms of resistance going a little higher, a little lower. But if you have like fairly if you have very rigid requirements for resistance and resistance, going even a tiny bit up or down, it can cause massive problems. And you probably want something that's a lot more accurate and, let's say, a lot less tolerant. But yeah, yeah. Okay, so brown and black, and I'm trying to remember because okay, so we call this a multiplier, right? All I do is just add zeros after that, which is basically what you would do. So 10 multiplied by 10, if 10 is the multiplier there, I just take that zero and add it to the 10. And so 10 multiplied by 10 is 100, right? Based on that, if orange is 1K and we are already at, yeah, is this a 10K ohm resistor? Is this a 10K or a 1K? I'm confused about that. I think it's a 10K. It's not gonna like be horribly dim. I don't think so. Wait, brown, black, orange, gold. Is this 1K or 10K? That is a 10K resistor. Right. Okay. Okay. You know what? Yeah, that's fine. I mean, I do have other resistors that I could use. I'm trying to stay away from the smaller ones because they have 5 bands and that becomes a little bit confusing. I have another one here, which is yellow. Hold on. We have yellow, purple, brown. Brown is the multiplier, which means adding a zero. Yellow is 4. Purple is, oh, it's a 470 ohm resistor. I'll take this. Now, give me a second while I assemble this circuit. Um, Sorry for the silence. I'm just assembling the circuit here. So we need positive on this side. Actually, I could have the thing on the other side, but then no, hold on. I think um it would be beneficial if I just set up ground. Yeah, if I set up ground, do I have one of those smaller jumpers? I believe I do. I need the smaller black jumper. I'll set up ground as an entire rail so I can then yeah. Okay, sorry about that. The thing was being a bit fussy for some reason. So I had to like turn it and okay, all right. So we have this, and then I can get another small jumper. I could directly put the resistor into that. Yeah, yeah. I don't usually do that, but then in this case it works. Yeah, I'll put the resistor directly into that. Okay, and then we have our give me a second. We want to put I can actually extend ground here. No, wait. This is our positive, isn't it? Oh, positive is on the other side. I put positive on the wrong side. Let's do it this way then. And then I can do ground here. And so ground is gone on that side, and then positive needs to go on this side. So we're going to use a blue wire. Blue might not be that obvious. Let's use a white wire. I'm looking for the smaller ones. I think I need to order more of these jumpers. I do actually have a bunch of jumpers though. I should take a look at my current stash that I've got, and based on that, I'll decide. I'm trying to find where D6 is. Yeah, I can't seem to find where D6 is. Okay, this is interesting. For some reason I'm having trouble finding. So I found D2, D4, D16, 17, D5, D18, 19, 21, 22, 23, 13, 12, 14, 26. Sorry, 27, then 26, 25, 33, 32, 35. Okay, what? Okay, whatever. I'll go with D12. Right. Hopefully I have wired this right. I think so. D12. Yeah. Okay. Um, okay. Now we haven't set up the code for this thing yet. Um, so I set this to 1 kilohertz. I don't know what the lowest can be. I don't know if this is even gonna let me. Like, is it gonna throw an error maybe, or like what's the situation? Let's find out. So we have our timer. I need to create the LED. So we're gonna change this uh, rename to LED 05. Did it change down there as well, or do I need to manually? Well, this isn't even the LED. Here we are changing what's happening with the pin. The LED itself is, what did I put that in? 12, I think. LED 12. Um, yeah, where are these? I'm curious about because I wasn't able to find specific ones here. I think the labels that I saw, they might have been because the pins have like overlapping functionality. So sometimes maybe instead of, even though it can be used as GPIO, but the fact that it can be used as something else as well, maybe that something else takes precedence and that's why they don't mention it. But yeah, LED 12. Why am I even calling this LED? Why not just, I don't even need this. If it's literally me having to type peripheral, um, I mean the only reason I would be doing this, yeah, yeah, there's like legit. It's all I have to do is pass in peripherals dot GPIO. So channel, we will create a channel here, similar to what we've created there. I think we'll try a different drive mode. What drive modes do we have? Let's there's only these two. So the driver actively sets, hold on. The driver actively sets the output voltage level for both high and low logical levels. I have, okay, cool. I didn't really understand that. Open drain output. The driver actively pulls the output voltage low for the low logic level, but leaves the high level floating, which is then determined by external hardware or internal pull up slash pull. This is more advanced functionality. I need to actually come across this for a certain use case in order to understand what's going on. So for now, I'm just going to stick with the push pull. Um, okay, let mute channel. Um, let's say channel 1. Actually, this would also be channel 0 technically, but because if we are looking at the the hardware, yeah, the low speed channel and high speed channel have different, sorry, they have identical indices in terms of like which timer it is. Um, okay, so let's give it a proper name then. Let's call it HC0 or HSC0. I placed that in the wrong place. Okay. Right. LEDC dot channel. I just remembered that I'd asked Gemini a question, um, and I never went back for that. Wait, this is asking for the channel. Back up. No, 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 back up. Oh, this is where we use the enum. So channel number, and we want to use channel 0. It's not specifying high or low, as in high speed or low speed. And then here we want to do peripherals dot GPIO 12. Okay, then wait, that's interesting. Somehow I got into the select mode, and I can't reproduce that now. Yeah, I can't reproduce that. Damn. Okay. Um, right. Then we do HS channel 0 dot, I guess it's configure at that point, right? Yeah, configure. So we want to configure that. We're gonna pass in a new config, config struct, And this requires a timer where we're going to pass in our HS timer as a reference, and then duty percentage. Uh, let's set it to 50%. Drive mode, push pull, and that should be, oh yeah, we need the unwrap as well. Okay, great. Then, uh, basically we are doing this same thing. I'm also curious about what it would look like. I think, okay, it wouldn't go from 0 to 1. I think the reason we have this ping pong effect is because we are going from 0 to 100 and then 100 back to 0. I think that's why. I don't think we would necessarily have this. Um, yeah, okay. Let's copy. You know what? No. Let's try this. Channel. No. What is it? HS channel dot start duty fade 0 to 100. 1000 is supposed to be the duration. So over the course of uh, over the course of a second, we are doing this. All right. While HS channel dot is duty fade running, do this. All right. So if I've done everything right, then we should be able to just do cargo run bin LED. What was it called? Underscore fade. Interesting. As it's connecting and still doing the whole flashing process, I can see D5 is floating, and so the blue LED, it lights up a little bit. This is interesting. There's a very different effect that this is having, and I'm wondering if this is because of the frequency that I set. So let's say I set it to 10K. Oh, actually, there was also the duty cycle that I'd set, right? Yeah, yeah, there was also the duty cycle that I'd set. So let's keep this at 1 kilohertz and set the duty cycle to 25. Okay, give it a second. Dude, is it always going to take this long? I mean, it's not a very big deal, but like I'm just wondering. Okay, let's try setting, and this is because I don't fully understand the math at play here. That's also why I've been trying to explore, how these numbers are working. But yeah, this could just be because I haven't fully understood the math here. Um, I don't fully understand, but I forgot what I was saying. But the point is that because I don't fully understand the math, so I'm just kind of like playing around with numbers rather than, you know, doing the math and making an educated guess about this. What did I change here? Okay, I set it to that. Okay. Okay, now it is on for the entire time. Interesting. So it must be the frequency. It could also be the fact that I've set a very low frequency. That could be an issue as well. Dude, the iteration time is a tiny bit slow. It's not that bad, but like in terms of, constant iteration, it is definitely a tiny bit slow. All right. Okay. Actually, let me change the positioning of these a little bit. Okay. Yeah, the LED should be a little more better visible now. Okay. All right. Something else worth looking into is the fact that we have these loops running. Um, this is running first, and then this is running, and then this is running. So I think it's like the entire loop is probably taking like a whole 3 seconds. No, I'm not sure. I'm actually not sure what's, and this is why we need to continue exploring this and don't like, and not just move forward and start looking into, the buzzer and other such projects, because I need to properly understand what's going on here in terms of like how the signal is being sent out, what the timing is. We need to properly understand this. So we have our high speed timer. Okay, let's say we don't do anything with this. Okay, we're gonna run that. It's gonna flash the image, and then only the red thing should turn on. Only the red LED should turn on. Okay. See, now it's happening a lot faster than it was before. So that while loop was definitely it was definitely interrupting things. So we need to understand what exactly is going on here. Okay. Um, for the time being, I'm wondering if I should just get rid of the high-speed timer. There was a tiny bit of a setup to do here. Like, holy shit. But yeah, I'm wondering if there's a bit of a setup that what? No, I'm wondering if I should just get rid of these so we can focus on, understanding what is going on. Or, I mean, I've written the code. I don't need to use the code. Yeah, yeah. So we have the timer. We have both the timers, HS timer, LS timer. Then we have the two channels. We are setting those up as well, but we are not using. Um, we're not using channel 0. Let me rename this. We're going to call this uh, LS. Why am I saying S? Speed. Low speed channel 0. And that did not change here. Shit. Back up. Yeah, let's do it from here. LS channel 0. Okay, let's do this and that and save. And now we just play around with this. Okay, that's our channel. This is our timer. We'll take the timer away from here. Oh, actually both the timer and the timer configuration. Take that away, create a line here, paste the thing here. Okay, so for now, we're going to be playing around with our high-speed timer. So we need to look into, first of all, let's see if from Hertz works and to what extent it works. So let's say 500 Hertz. Okay, so far it's not giving any errors. Yeah, I'm gonna need to like go back to the math on this to understand exactly what's going on. Okay, that's just on the entire time. Okay, wait, that's interesting. What if I do 50 kilohertz instead of 25 kilohertz? I think we can go higher, right? Okay, that's interesting. So it's stuck in that state. It's just not doing anything. Yeah, that's interesting. So the duty cycle is supposed to be 5 bits. Um, if we are, wait, here, let's say, okay, 5 bits. Okay. Um, so we have 2, 4, is this 16? 4 bits is 16. Wait, so 1, 2, so that's 2. This would be, oh, shit, I need to count, dude. Okay, okay, so that's our 4. So 2 bits is 4. 3 bits is what, 8, I think? Yeah, so if we are counting this as, well, this is 3. So we have 0, 1, 2, 3, 4, 5, 6, 7. 8 bits. 8 bits. Okay, so then 8, and then 16, and then 32. 5 bits is supposed to give us a max of 32. So what happens if I set this to what happens if I set this to 30 instead? Okay. Now we are back. Uh Now we have functionality again. So I guess the issue was that I set a frequency outside of what we could technically support, because I had set a duty resolution of 5 bits, but then I gave a value that goes beyond 5 bits. Um, I wonder if 50 would work, just to confirm this. So if 5 bits is 32, 6 bits would be 64, wouldn't it? 6 bits is 64, 7 bits is 128, and 8 bits is 256. Yeah, that's correct. So if we want to set this to 50, I would need to set the duty bits to 6 bit. Okay, let's see what the result is. It works. It does work. Worth noting is has the speed changed? I can't tell if the speed has changed. I wasn't paying attention to the speed before, but yeah, it does work. It does work. Um, we should look into. Okay, hold up. So this is one thing, right? We have our duty resolution. We're setting the resolution of each cycle in the number of ticks. So that's the max number of ticks that each cycle can have. And then our clock source is going to be the APB clock. So we are assuming it's 80 megahertz. And then we are setting a frequency of 50 with a resolution of this. So our highest, not resolution, our highest value, our highest frequency that we can set should be 64. Let's test that out. Let's try setting 64. I don't know if it's like the exact number. Actually, no, it's not 64 necessarily. Um, just like how, wait, no. In this case, it is 64. Yeah, no, sorry. In this case, it is 64. So 64 works. We know that 64 is the max. Um, what happens if I set 65? Yeah, there it is. Okay. So the issue there was actually I don't know how well you guys can see it, but at the very least, what you can see is that this LED is not um it doesn't have like a fading kind of quality anymore. For the sake of making it similar to what we had going on in the other thing, let's do that and paste. And here we're going to change this to 100 and 0. And now we should have. Oh, wait. Um, I forgot to change this. Yeah, take this back to 64 and now let's run this. So the iteration time, and I have no idea if there's anything that I can do about this, but the iteration time is definitely a tiny bit slow. And I don't know if it's going to become worse as my programs become more and more complex. But yeah, okay, there's our fading effect. So at the very least, you can notice that when we set this beyond the boundary of what the number of bits allows, then it's not fading anymore. At the very least, you can see that it's not fading. Instead, it's just there. It's dimly lit. It's not even like fully lit, but I don't know how well that comes across on camera. I think it does. Yeah, it comes across pretty decently. Yeah, yeah. All right. Um there's a lot to explore here. We are definitely going to continue exploring this tomorrow as well. We might need to go back to the math, which is somewhere here. Well, not this one, but was it this? No, no, I need to open up that page again. It was this. Uh, yeah, yeah. So, we might need to come back to this because I really want to understand what's going on here. I'm gonna feed this code into I'm gonna feed this code into Gemini and ask it to explain the whole thing to me because there's a bunch of things that have happened here, right? We've created our timer, and then we configured our timer. Then we created the channel, and we configured the channel as well. Or we grabbed the channel, I guess I should say, because it seems like whenever it's these hardware components, we are saying that we are grabbing it from what I'm assuming is the singleton. The singleton, in this case, we have actually how yeah, no, I shouldn't say about the singleton thing because the singleton thing comes in for peripherals, so you don't accidentally have two separate sets of peripherals defined. That's why you need the singleton. But then by that logic, wouldn't the same thing be said about LEDC as well? Oh yeah, we did exactly that. We grabbed it from the peripherals. This API is marked as unstable and is only available when the unstable created. Okay, yeah. This comes with no stability guarantees and could be changed or removed at any time. Okay, all right, great. Um, but yeah, yeah, lots to explore here, even in this very simple uh, example. There's a bunch of stuff to explore. So we are gonna take our time with this. We're gonna dissect this. We're gonna basically be I was gonna make a dumb joke. I was gonna say like we're gonna be like medical students and like take a body part and just like dissect it and study it and but we are kind of doing that. We are basically dissecting this body part. We are dissecting our entire program. Actually, no, we are dissecting this body part. We are dissecting this part of the entire program. This part of the program. So I guess it kind of the dumb joke I was about to make, it does kind of like make sense here. But yeah, good progress today. Pretty decent progress today. And now I need to get back to working on or studying about Wes term stuff. There's lots and lots of questions that I need to ask Gemini or Claude in this case, not Gemini. Um, Fortunately, GitHub does give us at least 50 requests, I think. And I think it's 50 requests per month, maybe. I don't know. I'm not sure. I'm gonna have to look into the quota thing. But yeah, for free, they give us a certain number of requests, and my quota for this month was, replenished recently or refreshed recently. So I'm making good use of it. I'm gonna study all of West term using that quota, and just so I don't lose the entire conversation, I'm using GitHub's feature of being able to export the conversation as a markdown file. That's actually great that they give us the option to export the entire thing as a markdown file. So I've done that. I'm doing that like frequently to save the conversation. And yeah, dude. Yeah. Okay. Now, um, give me a second here. I know that we didn't raid anyone yesterday, so I wanna I want to try rating someone today instead. I don't know what this person is. Is this person talking right now? I don't think so. I also don't know what their timer is at. Okay, no, we'll pick someone else then. Um, it says here CHN. I think that means China. Exporter learns EG or ENG. Oh, that's English. I thought it was saying engineering. Give me a second. I'm just looking and looking. Okay. I think, right. So there's this person who is apparently making labels for their TCG. I think that's trading card game collection, and also yapping. Right. So we're gonna go to this person. I don't know if they have their raids like limited or no, it's not limited. Okay. All right. So that's going to be it for today's stream. We made some good progress today. I'm happy with the progress. We're going to continue this tomorrow as well. And we're going to dive deep into understanding the math that's going on here. We need to go back to the basics and kind of like figure out that whole, the base frequency and then what that's being divided into and how we are getting our numbers here and how that's affecting things physically. We have to explore all of that. So we are probably going to be spending tomorrow and maybe the next like the next 2 or 3 streams on just that because I don't want to move past this point until I properly understand PWM. But yeah, that's going to be it for today's stream. I hope you guys have a nice day, and I'll see you all next time. Peace.